Alright, so, and to give you guys a heads up, we are, with 3 weeks left, we're going to do lessons and stuff this week and through about half of next week. So there will be 3, maybe 4 lessons left total. So, because remember, we do a lesson, then we practice it. So, 3 or 4 left total, and then after that, it'll be, you'll have a little mini test, and then you'll have like a makeup work, a couple of makeup workbooks. So, we're going to look at scientific notation today, which you guys maybe did in science class.
And that looks
also some good math stuff.
really confusing.
Scientific notation? Yep, that's why we're going over it. So, scientific notation is a way of writing either really, really big or really, really small numbers. So, if we have scientific notation, so if you have scientific notation, it always starts as having a number in front, and this number is between is in between 1 and 10. So we always have a number between 1 and 10. So it'll be between 1 and 10 at first. Or it could be -1 and -10. It doesn't really matter as long as the actual number is between 1 and 10. So scientific notation always starts out with that. And then it will have a times sign. And then after that it will have a 10 and then an exponent on this 10. And this exponent will not have decimals. So it'll always be a number between 1 and 10, or -1 and -10. Then it'll have a times sign, and then it'll have 10 to a number up here. So that's how scientific notation will always look. Number between 1 and 10, a times sign, and then 10 to some exponent number.
So these are
Yes, so these are some examples. So, for example, this first one, 8.3, that's between 1 and 10, right? So that works. And then times, we got our times sign, and then 10 to the 5th. That's fine. The next one, 4.12 is between 1 and 10, times 10 to the 22nd, that's fine. This last one, 7.1 is between 1 and 10, times 10 to the, and that's a -5. This number could be negative. It doesn't matter. So the only thing that matters on this number is no decimals. On this number on the 10. Okay. So, we're going to work with this scientific notation, and what we're going to do, for the most part, is practice going back and forth between regular numbers and scientific notation. So, we're going to start by going from a regular number into scientific notation. So we're going to write the approximate distance between the Sun and Saturn, which is, let's see, 1,430,000,000 kilometers. So the reason we use scientific notation is because, do you really want to write out this number right here like 10 different times? No, it's really big and annoying, right? So what we're going to do is we're going to convert it into scientific notation. So we have about basically two steps. So to start with, is there a decimal on this number? And I'm actually, let me just write it a little bit bigger first. So 1, 4, 3, 0.
Wait, that's a 4?
0, 0, 0, 0, 0. Okay. So to start with, I need to figure out where the decimal is. Do we see a decimal on this right now?
No.
No. But there's going to be one at the very end, right? I could go like 0.0 if I wanted to. But I'm just going to put my decimal here at the very end. And what I'm going to do is I'm going to move my decimal left until it gets between the first and second number. And when I do that, I'm going to count how many times I went over there. So I'm going to take this decimal and I want to put it right here between the first two, between first and second. And I just need to count the spaces in between. So if I was to move this decimal, I'd be going 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yikes.
So I moved it 9 times, and I'm going to write that down because I'm going to need this number in a minute. So we're not going to use it yet, but we're going to need it in a minute. Okay, so that was our first step. That was step 1. Step 2 now. You see how I have all these extra zeros at the end? We're going to drop all those zeros. We're going to get rid of them. So I'm going to get rid of all these zeros now. And I'm just going to write down 1.43. And I'm going to drop all those zeros. And that's like the first number in my scientific notation. That's between 1 and 10, right? So that's perfect. And then I need to put my times sign. And then I need to put my 10. And the 10 needs a number for an exponent. That exponent is this 9 that I counted earlier. So 1.43 times 10 to the 9.
Oh.
Oh.
And that's it. That's it. What? Alright, so we're just going to practice writing some of these in scientific notation. Some of these numbers are going to be. So, the first step, we're going to do this first one, is I need to do a little more space. Okay, so the first thing is I need to find my decimal, and since I don't have it, I'm going to put it at the end here. And then I want to put my decimal between the first two, between the first and second numbers, right? So I need to count how many I need to go over to get between the first and the second. And that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was 9. I'm going to write it down so I don't forget it. It just happened to be the same as last time. That number will change on different problems. They just happen to be the same. Okay, so that was my first step. Move your decimal between the first two and count how many times you moved it over. So I moved it 9 times. So I'm going to drop all these extra zeros at the end right here. So I don't care about these zeros anymore. And I'm going to write this down without the zeros. So 6.5879. And when I do this, drop all the zeros at the end. If you ever have like a 0 in the middle, like if this was like a 6508, I would keep that 0 in the middle, but all these at the very end, you get rid of them. Okay, so I have my first number right here in the front. Then I'm going to go times 10, and I put that exponent on the 10, and it's the same as I counted over.
Is it always going to be 10?
This piece right here, this number will always be 10, yeah. So every problem is going to have times 10. Every single problem.
Okay.
Every single problem is going to have times 10. This number in front is going to change, and the exponent's going to change. Okay.
Wait, go.
Yeah.
So, why did you put 9?
Because I counted over, so the decimal is here at the end, right, when I started?
Yeah.
I counted over 9
so
times.
it's like how many times you count?
Yeah, how many times you count, that's all it is. So this next one, it's not going to be 9, it's going to be bigger because there's more numbers, right?
Yeah.
Alright, your guys' turn. First in class problem, I want you to write this in scientific notation.
I'm already done.
Good time. Help Juice if you need it. So, on your own, write this number in scientific notation. Let's see what you get. Then we'll go over it together. Sit tight. If you already did it, sit tight. How about your partner if they need it?
Do you just want us also just write this symbol as well?
What do you mean? Oh. I did use pi as the example, but you know. Nice catch, though. The first person who said anything about that. Didn't you do this one already?
Oh, God.
That's the first part. Keep going. That was step 1. I do step 2.
I think it might actually like science. So far.
So,
What? Maybe you.
It's not getting the signal.
Always weird one this way. Oh, now you say it. Now you say it.
What do you want me to take you?
So I'll give you about another minute. These can be kind of time consuming sometimes.
I'll show
Don't worry
you.
about that. Then we'll go over it together.
Is that times
Did we do
10
that
to the
number?
ninth?
Oh,
Is
This
that
one
times
is.
10 to the 9th?
This one is, yeah. On your in-class problem, it won't be times 10 to the 9.
Can I do it?
We'll see. You guys help me out?
Alright, can I go to
Would
the
you-
bathroom real quick?
No, we're not done. After the lesson.
What? How do you want?
Alright, let's get started. So, let me see.
Can you help?
Alright, Juice, start us off. Where do I need to put the decimal between?
Yeah,
On the beginning?
I did.
Between which two numbers?
Oh, 0 and 3.
Can you
The
help?
what?
0 and 3.
Not the 0 and 3, the...
Oh,
I mean the 3 and the 1, right? Okay. Alright, so I gotta move this decimal all the way over between that 1 and the 3 there. And on that one, how many times am I gonna move it over, Susie? 14, right? Okay. So I am gonna move it over 14 times. Okay, Trayton, I counted over how many times I'm moving it, right? What do I have to do next?
Drop all of
Yep, we gotta drop all these extra zeros at the end. So I don't care about those zeros anymore. So 3.141596.5.
I thought that there could be something social security number.
Sounds like it. And then we go times 10. And that's where that 14 comes back now. Times 10 to 14.
Thank you for teaching us this.
No problems. Alright, that's what we get.
When do we get to graduate?
3 more years, man.
Oh, God.
Okay. So that's it. Good job. We are going to, I think I'm actually going to cut this lesson in half. We're going to do 1 or 2 more, and then we're going to do the other parts later.
This is actually pretty easy.
Yeah, it's not too bad. Okay. So, so far, all we've done is go from really big numbers, right? Every number we did so far was really big. We're going to look at a really small number now with decimals, with a decimal in it already.
Oh.
So, I've got this really long one, right? But
Yeah.
I've got my decimal here in the very front, and so it's slightly different. So, before, my decimal was at the, on all these other ones, my decimal was at the right side, and I had to move it to the left. This time around, it's already on the left, and I have to move it right. So it's going to be almost exactly the same, but we got to tweak our steps a little bit. So what I'm going to do is I'm going to move this decimal, and I'm going to move it until right after the first number that's not a 0. So when I go over, my first number is not, that's not 0, it's this 4, right? That's where I want to put my decimal.
So then it becomes 4.89.
Yeah. So I'm going to put my decimal here. Last time, I brought it like almost to the very beginning. This time, I just want to skip all these zeros in front, and I want to put it right after the first non-zero. So 4. Okay? Just like last time, I need to count up how many times I'm going to move it over. So 1, 2, 3, 4, 5, 6, 7, 8, man, just happens to be 9 again. I'd probably change these and make it so they're not always 9. Okay, so I am going to move it over until I have 4.89. Let's see, I moved it 9 times, right? Better write that down so I don't forget it. Okay, just like last time, I'm going to drop all these zeros in front. I'm going to drop all those zeros in front, and I have just 4.89. Okay? And just like last time, I'm going to go times 10. And I'm going to put on 9, just like last time. But I have one last thing. So I moved my decimal. It moved over here to the right, didn't it? That means whenever I move my decimal to the right, that exponent, this 9 I put on, it's not going to be a 9, it's going to be a negative 9.
But, oh, because it's going the other way?
Yep, because it's going the other way.
Duh.
So, on the first ones I did, I moved that decimal left. When you move it to the left, your exponent's going to be positive. But if you got to move it the other way, to the right, your exponent's going to be negative.
Positive.
So when the decimal goes left, it's positive. When the decimal goes right, it's negative. Mhm. Otherwise, it's pretty much the same. I mean, they're a little different going back and forth, but they're not super different. So let's do one more like this, then I'll have you guys do one, and then we're going to skip the rest. So let's actually skip part A, and let's do part B. Let's do
You
part
can't
B.
start the alphabet without an A.
Ha 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 ha.
Hey.
You know what? I'm going to start season.
But you're going different directions, right?
I mean, I watched like 4 episodes with them all, but like.
Alright, so on this one, we're going to do part B here. So, I have my decimal here on the left side.
I'm just saying this for
I have my decimal here, which means I need to move it to the right. And whenever I move it to the right, I'm going to put it after the first thing that's not a 0. So in this one, Dylan, what's the first number that's not a 0? Going towards the right. Going to the right of my decimal. Yep. So I'm going to have to put my decimal right here between the 3 and the 2. And just like last time, I need to count up how many over I need to go. So, let's see, 1, 2, 3, 4, 5. So it's 5. But what do we say because I'm going to the right? Is it going to be positive 5 or negative 5? Negative. So whenever you go right, it's a negative number. Alright, so I put my decimal between the 3 and the 2. I get rid of everything. All these extra zeros in front now, they don't matter anymore. Alright, so I have 3.2. I have I'm going to put my times 10 next. And then I'm going to put this negative 5 on it. And that's it. We're done. Okay. All right, you guys are going to do part B on your own as your last in-class problem, and I'll give you a little hint to get started. So we're gonna have to move this decimal past the 7, right?
Yep.
So that's the first non-zero. So when you move it past the 7, when you write it down right here, you're just gonna write 7. Like that. You're not gonna have a point or anything. So it'll be like 7 times 10 to the something. So you're gonna have to figure out the rest. So you gotta move the decimal to the right. You gotta figure out how many,
I dub Z.
what your exponent's gonna be. So on your own, finish this last one. We'll go over it, and then I might have to make up an exit ticket for you because I don't think mine's gonna be on there. Actually, we can do them. Yeah.
Why don't we just do A?
Because we already did ones like A. We're also skipping C because we already did ones like C.
So we're doing D.
We're doing D.
Where's D? Oh, is that it right there? I know.
So on your own, on your paper, write this in scientific notation.
So, okay, so you know how you have to, like, go on the other side of the 7?
Yeah.
You put 7.0?
You could do that. That wouldn't be wrong.
What's that, 7.1? Can you put
No. It would have to be 7.0 or just 7.
I'm gonna put 7.0.
That's fine. Perfectly fine.
7.
It's a pretty good show.
Yeah, I'm done.
Okay, good. I'll give you 30 more seconds. Are you done, Alex? You, Jeremy?
I'm done.
That one person that reminds the teacher about homework. Welcome to your tape. Stop me getting you drunk.
Move the decimal to the right. So should that be a positive 7 or negative 7? Negative there. Yeah, we just be able to put it down to that oval. Yeah, perfect. Alright, let's go over this one.
Bulky, can I ask a question? Is it appropriate?
Is it relevant to what we're doing right now?
Oh, no, not
Maybe after the lesson.
Right.
Okay. So on this one, Creighton,
Yo.
how many times we got to move the decimal?
Times.
For D. Or part D.
D.
I should probably not listen. Yeah, let's count. So we got to go 1, 2, 3, 4, 5, 6, 7. So it's got to be 7 times, but it's going to be negative because we're going to the right. So remember, if you aren't sure, copy down this little thing we did before. If your decimal goes to the right, it's negative. If your decimal goes to the left, it's positive. So we already did that. It's going to be a 7 in front here, because that's what I put my decimal after. Then we're going to have times 10 to the negative 7. If you wanted to, you could have gone 7.0 times 10 to the negative 7, like Richie was saying. But it doesn't matter either way. These are both the same thing. So either one of these will work. Alright, so we're going to stop the lesson here, and I'm going to split this into 2 days. So, skip these for now. Skip these ones. You guys are going to do your exit ticket, but on your exit ticket, only do questions 1 and 2. For questions 3 and 4, just type in, like, skip.
Ooh,
Or something in.
we skipping out here.
So, do question 1 and 2 on your paper, and then type them into Socrative.